How you doing? Thank you for tuning in to this here video presentation by Mr. Larry Whittington, or as he want to be known, Mr. Whit. Mr. Whittington's know all about mathematics, and that is why he founded the Fort Bend Tutorings. Today we're going to learn about word problems. Not the kind where you curse people out, but the mathematical kinds. The kind I don't be understanding at all. Alright, get your ink pen and your pencil ready. Take notes, because you finna learn from Mr. Whit.
Hello ladies and gentlemen, this is Mr. Whit with Fort Bend Tutoring, and today's tutorial we'll be talking about joint variation. That's right, joint variation. And what is joint variation, you may say? Well, it's a form of variation where you'll have a variable that varies as the product of two other variables and or functions. Basically, you'll have more than one thing multiplying on your constant of variation here, and that's why they'll call it joint variation, that the product of these two separate functions are multiplying with your constant of variation. And speaking of which, it's this constant k that we'll be calling our constant of variation or our constant of proportionality. It all depends on your reference, your author, your textbook, your teacher. You get my point. All right, so let's see about some problems. Okay, in problem number one, we have if f varies jointly with u and v, and f equals 36 when u equals 3 and v equals 4, they want us to A, write the appropriate equation connecting f, u, and v, in other words, the variation equation, and B, they want us to find f when u equals 5 and 2. So the first thing I'll do is I'll set up my variation equation. So we have our variable f here, and we know that it will be varying jointly with our variables u and v. So here's my setup, just like that. F equals our constant of variation times the product of u and v. That's what we have. So what we'll be doing now, in order to find out our constant of variation, we'll be plugging in those values of f, u, and v that our problem gave us. And that is, we know that f is 36 when u is equivalent to 3 and the variable v equals 4. So once I have this, we'll go ahead and multiply on that right side. And we know that 3 times 4 is 12, right? So that gives us 36 equals 12k, and then in order to solve for k, you want to go ahead and divide both sides by 12. That's right, that division principle of equality. Go ahead and hook that up. So from here, we'll have the 36 divided by 12. That gives you 3, which is your value of k, which is your constant of variation. So let's say that the problem simply asks you for the constant of variation or the constant of proportionality. Well, the answer would just be 3, okay? Just that 3 right there. You know what? I'm going to go ahead and circle this. I'm going to circle this in green so that we'll keep up with the value, that constant of variation. And using this constant of variation, we'll be able to rewrite our original variation equation with the constant of variation in place. So it'll read f equals 3uv. And it's this equation right here, that f equals 3 times u times v, that's the equation that connects f, u, and v. Yeah, I'm going to put a red box around this. That's right, I'll be red boxing my answer. That's right, red boxing it, because that's what I do. Part B wants to find the value of f when u equals 5 and v equals 2. So what are you going to do? In order to find that value of f when u equals 5 and v equals 2, we'll be using our variation equation. Yeah, the equation of our joint variation when we already are aware of what the value of k is, that constant of variation. We plugged it in, remember? So since we're plugging in things, we'll be plugging in a new value of u and v. So for part B, they want us to plug in a value of 5 for u. So let's get that 5 in there, okay? And then our value for v is 2. Go ahead and plug in 2. All right, there you go. So now that we have the values of our equation plugged in, we can now solve for f. Let's go ahead and get that in view. Get in view. Get in view. There you go. No, not quite yet. There you go. And so multiplying, we'll have f equals 3 times 5 is 15, right? All right, we'll show it. We'll show it. I'm not scared of you. I'm not afraid of you. There we go. See, I'm just showing. Just showing that I know what 3 times 5 is. And then 15 times 2 is 30, which is the answer to part B. I'm going to put a red box around it. I have to. Red boxes go around our answers. Yes, to let your teacher know you know the answer is 30 for part B. So number 1 is answered. Let's move on to the next problem. That's right. We're gonna move on to this next problem right here. Problem 2 says, assume x varies jointly as y and z. So let's go ahead and just set that up for now. So we'll go ahead and write our equation as x equals k times y times z. That's a z, by the way. Yes, I know it's ugly, but so are other things in life. Okay, so are other things in life. You don't know what pretty is until you see ugly. Okay, so there you go. It has a purpose. Also, x equals 9 when y equals 2 and z equals -3. So if I'm to answer part A, where it says find the variation equation, I need to use these values in the original problem, that standard that's given to me, in order to find my constant of variation, the k value. So let's get to plugging things in. Let's substitute. So we know that x equals 9 when y is equivalent to 2 and z is equivalent to -3. So here we have our values plugged in. Are your values plugged in? Because mine are. Okay, so get to plugging things in, all right? I'll be bringing down 9 now, all right? And I know that 2 times -3 is -6. So I have -6k thus far. Solving for k, I'll be dividing both sides by -6. Are you dividing by -6? Because I am. And then I'll be simplifying the 9 divided by -6. This gives me -3/2. See, that's my value of k. This is my constant of variation. Yes, I'm going to put another green circle around it, and you can't stop me. There you go. There you go. There's your green circle around your constant of variation. And we'll be using that value, by the way, to write our variation equation. So I'll rewrite our equation as x equals -3/2 yz. There's that ugly z again. What you going to do? That's what I thought. Okay. So now that we have our constant of variation plugged in, we now have our variation equation, which is the result of part A. This is our variation equation. That's right. And I have a red box around my answer. What color is your box? Okay. Mine's red. Just saying. I got a red box. Part B, find x when both y and z are 4. So both y and z, it will be 4. I'll be plugging that in. And then we'll simplify the equation in order to solve for x. Yeah, let's get to doing that. So I'll rewrite this as x equals, why is it blue? Why is it blue now? I clearly wanted black for this problem. Let me try this again. We'll have x equals -3/2. My value of y is 4. The value of z is also 4. Yes, it is. Yes, it is. This is what I have now. Okay, you were watching. And now I'll be able to simplify this. Now, I don't care for the fraction, but I will do this. I will say that 2, it goes into itself once. It goes into 4 twice. You see, I was able to simplify that. So now I'm able to rewrite this as -3 times 2 times 4. Because who likes fractions? Not me. Not me. We're going to multiply this out. We have -3 times 2. That's -6. -6 times 4. That's -24. I have an answer now for part B. This is the answer. Put a red box around it already. Red boxing it. Done, son. All right. That was problem number 2. Let's keep it moving. We got this joint variation going on here. That's right. Joint variation going on here with you. Problem number 3. So for problem number 3, we have z varies jointly as x and y. Find the mathematical model and constant of proportionality, aka the constant of variation. You see how they try to trick you out? You see? Who knows this as the constant of proportionality? No one. No one knows this. All right, so they try to trick you. It's the same thing as your constant of variation, aka the k value, the k variable in every variation of the problem. All right, so that's what they're referring to, okay? That represents this statement if z equals 64 and x equals 4 and y equals 8. A lot of numbers. Let's go ahead and set up our variation equation, shall we? We know it's a joint variation equation because they said varies jointly. All right, so there's that key word. So I'm going to set it up as z, the ugly z. Thank you. I know your z's look better. Okay, you don't have to hurt people's feelings. Equals k times x times y. There you go. That's my setup. Based on our given information from the problem, we know that our value of z is 64 when x equals 4 and y equals 8. Yeah, we know that because the problem told us. Simplifying our equation, we now have 64 equals 4 times 8, which is 32k. And then I'll be dividing both sides by 32. Simplifying that to end up with 2 for our value of k, that constant of proportionality. Can I even say that right? Proportionality. Yeah, okay, there it is. So our constant of proportionality is 2. So because part A requested us to find the constant of proportionality, we're going to red box it. Oh yes, because this is the answer to part A. Red boxing it, just like that. Now for part B, they want us to write the equation showing that z varies jointly with x and y. Well, in order to make that happen, all we have to do is plug in our constant of proportionality into the variation setup that we have here. So in order to write our joint variation equation, we'll simply replace k with 2. So the variation equation is z equals 2xy. And that's it. Yeah, that's the equation showing z varies jointly with x and y. Done. Exactly. Let's go ahead and put a red box around that. Red boxing it. And that is problem number 3. In part 4, n varies jointly as t and p. When t is 2 and p is 2 5/10, n is 15. All right, well, that's nice and sweet. Part A, they want us to find the constant of variation. So in order to do that, I'm going to go ahead and write my setup for my variation equation. I'll have n equals k times t times p. In order to solve for my constant of variation, we'll be plugging in the following information from our problem. We know that n is equivalent to 15 when t equals 2 and p equals 2 5/10. All right, good. Simplifying on the right side here, that 2 times 2 5/10, and we now have 15 equals 5k. All right, well, from here, all you have to do is just divide both sides by 5. Yeah, just do that. So you'll end up with your constant of variation being equivalent to 3. Yeah, 15 divided by 5 is 3 still. Go ahead and put a red box around that because that's part A. Red boxing it. Oh, you know it's coming. Now that we have our constant of variation, go ahead and write that variation equation. You already know what it is. It will be n equals 3tp. That's it. This is our variation equation, and we'll be utilizing this variation equation to solve for p when n equals 367 5/10. What number is that they're using? Oh, that's just ugly. And t is 7. All right, well, that's just ugly. However, continuing this problem, we'll have 367 5/10. This equals 21p. So go ahead and divide both sides by 21. And when you simplify that, p equals to 17 5/10. And that's our answer for p. All right, there it is. Stop being stingy with your red boxes. Go ahead and put a red box around your answer. Stop playing around. That is problem number 4. Yeah, we're just moving along. That's all we're doing. Let's move on to the next problem. Oh, wow. Number 5 looks like it has a lot of words. We don't like words. The amount of simple interest earned in an account varies jointly as the amount of principal invested and the amount of time the money is invested. If $5,000 in principal earns $750 in 6 years, determine how much interest will be earned on $8,000 in 4 years. Wow, that was a book. For part A, it says, write the equation of variation. All right, so let's go ahead and start with our setup here. It says the amount of simple interest earned, so my simple interest is going to be I, equals, that's my constant of variation. It varies jointly as the amount of principal invested, so I'm going to use P for my principal and the amount of time the money is invested. So I'm going to go with T for time, and this is my setup for my variation equation. In order to find out my constant of proportionality, aka the constant of variation, we'll go ahead and use the information given in the problem to solve for our constant. So let's go ahead and do some substitution here. They say that the principal will earn $750 in 6 years, so that means that my interest earned is $750. The principal amount invested is $5,000, and the time that is sat in that account was 6 years. Continuing on, we'll have 750 equals 30,000 K. Dividing both sides by 30,000, all right, there's a lot of zeros there. Okay, we'll end up with our constant of variation being equivalent to 25 thousandths. Yeah, that's the constant of variation, 25 thousandths. Which is basically the rate of interest that was used on the account, which if you were to convert that would be 2 5/10%. That's how your constant of variation can be interpreted in this problem. Now that we know our constant of variation, we can now write our variation equation as I equals 25 thousandths PT. And this is your variation equation. Red boxing it. Just like that. That's the answer to part A. From here, we're asked how much interest will be earned on $8,000 in 4 years. So let's use this variation equation to solve for it. Now that we have our variation equation, I know that I equals 25 thousandths. Our principal now is going to be $8,000, and the time is going to be 4 years. So here we have our setup thus far. So from here, all we need to do is simplify. So once you multiply 25 thousandths times 8,000 times 4, you'll end up with $800. That's going to be the amount earned over 4 years. If you invest $8,000 in an interest-bearing account, that's 2 5/10%. Yeah, there you go. All right, I'm going to red box this because it's the answer. Red boxing it. And that is problem number 5. Let's move on. Okay, so once again, a lot of words. The work W in joules done when lifting an object varies jointly with the mass M in kilograms of the object and the height H in meters that the object is lifted. The work done when a 120 kilogram object is lifted 1 8/10 meters is 2,116 8/10 joules. How much work is done when lifting a 100 kilogram object 1 5/10 meters? A. What's the equation of proportionality? AKA, what's the variation equation? B. How much work is done when lifting a 100 kilogram object 1 5/10 meters? Don't you just love word problems? Don't they just make you feel all warm and tingly on the inside? Yeah, me too. So let's start with our setup here. We know that the work being done here varies jointly with the mass M and the height that the object is lifted. Using the information that's given to us in the problem, we know that the work done is 2,116 8/10 joules when a 120 kilogram, that's going to be your mass, is lifted 1 8/10 meters, and that's going to be your height. And so here we have our setup of the problem. We'll be using this information to solve for K, our constant of proportionality. So I'm going to start by multiplying that right side out there. So 120 times 1 8/10, that's going to be 216 K. From here, we'll be dividing both sides by 216. And once we've done that, our constant of proportionality is going to be 9 8/10. Using this constant of proportionality, we can write our variation equation or our equation of proportionality as W equals 9 8/10 MH. Just like that. All right, and that's part A. Let's red box it. Red boxing it. So let's use this in order to find out how much work is done when lifting a 100 kilogram object 1 5/10 meters. So here we have our variation equation, our joint variation equation, and we'll be lifting, finding out how much work will occur when we're lifting a 100 kilogram object 1 5/10 meters. So from here, we just got to multiply everything out, right? So this is going to be our work equals, and if we multiply 9 8/10 times 100, that would just give us 980. Yeah. Then we'll multiply that times 1 5/10. What are you going to get? That gives us 1,470 joules. All right, let's go ahead and write that unit of measurement there. There we go. So 1,470 joules, red boxing it. That's right, red boxing it. And that is our answer for part B. And this, ladies and gentlemen, completes our video on joint variation. I hope you enjoyed it. I know I did. And if you really did, go ahead and like the video and subscribe to our YouTube channel, Fort Bend Tutoring. And if you're able, go ahead and click that donation button, because that helps us bring you more free math videos from me, Mr. Witt, and Fort Bend Tutoring. Peace.
We're going to be learning about such things as linear, quadratics, system of equations, tables, mixtures, work, oh Lord, distance, interest, of which I don't have much, investment. This is my favorite one. I'm going to name my grandbaby consecutive integers, algebraic translations, and percents. I understand a little bit about percents. I know that 50% off is pretty good.
Yeah, you already know. I'm going to multiply both sides by 2. You already know this. You already know this. I don't even know why you're testing me. All right. I'm thinking maybe you're a spy. Maybe you're a spy checking in to see if I'm teaching people correctly.